On this example, we're given an angle theta, 5 pi over 3, and we are asked to find each of the 6 trigonometric functions evaluated at 5 pi over 3 at theta. So to do so, what we're going to do is we're going to find a reference angle first. And to do this, I'm also assuming that we have down these 3 very special angles, the pi over 6, pi over 4, pi over 3, and their corresponding values at cosine, sine, and tangent. So as we get going here, I first look at 5 pi over 3 and I place it in the correct quadrant. So as you can see, I've gone ahead and listed out our quadrantal angles, pi over 2, pi, 3 pi over 2, and 2 pi. Now the angle that we're given, 5 pi over 3, that's an improper fraction, so it goes past 1 whole pi, and it's going to be either in the third or fourth quadrants. 3 halves pi, or 3 pi over 2, is the same thing as 1.5 pi's or 1.5 pi's, whereas 5 pi over 3 is the same thing as 1 2/3 pi's. Therefore, what's going to happen is this is going to be bigger than 1.5 pi's. It's going to wrap all the way around into the fourth quadrant. Now that's important because we're going to be finding the angle between that one that we just drew, the 5 pi over 3, and the x-axis. We're going to refer to that as theta bar. That's going to be our reference angle. So to wrap around this far was 5 pi over 3. But we want whatever theta bar is, the reference angle that wraps the rest of the way around back to the x-axis. So to calculate theta bar, what we're going to do is we take the further of the two sides of this angle, which will be 2 pi, and subtract away the shorter one, which is the 5 pi over 3. Now we can kind of strategically rewrite the 2 pi as 6 pi over 3. That'll be the same thing as 2 pi minus 5 pi over 3, which is going to leave us with pi over 3. So pi over 3 is what we refer to as the reference angle. All right, now what we want to do is we want to plug in the reference angle, evaluate sine, cosine, and tangent at that reference angle. But to do so, we want to be very careful that we get the correct sign for evaluating this. So to do so, I use the mnemonic device, all students take calculus. This just helps us that in the first quadrant, all of them are positive. In the second quadrant, sine is positive, third quadrant tangent, and the fourth quadrant cosine is going to be positive. All right, now let's get to plugging this in, and we'll also incorporate the correct sign. So remember, cosine is going to be positive, but everything else is going to be negative. So we have negative sine of pi over 3. We have positive cosine of pi over 3. And we have negative tangent of pi over 3. All right, from there, what we can do is hopefully we have these memorized. Pi over 3, when we evaluated it at sine, is going to be square root of 3 over 2. But remember, it's negative square root of 3 over 2. On cosine of pi over 3, it's going to be positive 1/2. And then for tangent of pi over 3, it's going to be the square root of 3. But in our case, it was negative out in front because our initial theta was in the fourth quadrant. All right, now to get cosecant, secant, and cotangent, what you really want to do is remember that these are the reciprocal identities, that cosecant is linked up with sine. So what you can do is simply flip it upside down, take its reciprocal, and you get negative of 2 over the square root of 3. And we can clean that up a little bit by rationalizing the denominator by multiplying numerator and denominator both by square root of 3. So we have negative 2 square root of 3 over square root of 3 times square root of 3 is square root of 9, which works out to be 3. Secant, very similarly, you're going to take the cosine and you're going to invert it. You're going to go 2 over 1 instead of 1 over 2, which can be reduced down to 2. And then finally, cotangent, you can kind of visualize this as a fraction as being over 1 if you'd like. So it's going to be 1 or negative over of 1 over the square root of 3. With a little rationalizing, multiplying by square root of 3 over square root of 3 and getting rid of that radical from the denominator, we're going to have negative square root of 3 all over 3. Really isn't too bad. Just make sure you locate the correct quadrant every single time of where your initial theta is located. Draw your reference angle, theta bar, always to the x-axis, and then make sure you get the correct sign on each one of these. All right, hope this helps. Good luck.